Hi everyone, welcome back to Coding Ninjas. Today we are going to talk about how can we build a image sharing service like Instagram. When you talk about system design is the most significant part of software architecture. So, it is a bit intimidating when you talk about freshers coming into this line because this does not has any standards. You're going to see different approaches at different places. So again, this becomes very complex because there is no standard approach to such type of question. So when I talk about this particular video, I'm going to talk to you in a very minimal most level in which we are going to build a basic approach and how can we design basic building blocks of Instagram. So whenever you are in such kind of interview, you should always set out your goals. You should know what you are actually working on, and whenever you go in an interview, you should talk about the specific area where your interviewer is interested in, because such kind of interviews can go very long and there are a lot intricacies when we talk about a whole system design architecture. Actually, it is a very big one. So even a single component can take you like your whole particular interview. So never do it on your own. Just try to ask it from your interviewer, what does he expect from you in this particular uh, interview. All right, so you're here with Instagram. So when you talk about Instagram, so Instagram is a social media platform that enables user to share their videos, share their photos, all right, with others, which are actually mostly the followers here. So a user can typically upload his photos, videos. Nowadays we are having reels, but that is not the scope of this particular video. They have a news feed in which they can see everything, the top uploads of all the people that a person actually follows. There are lots and lots of things. I know you all might have actually used Instagram, but whenever you are in an interview, you should always start with the very basic. You should just design on the very core principle, because again, you might know how Instagram works, what are the actual things that it offers, what actually the product contains, but you should never actually tell them that hey, this is the feature that you can work on. So again, this can be very grilling. So we are going to actually talk about very basic replica of Instagram here. So again, whenever I start a video, all right, we always start with two things. We should first set out what are the functional requirements as an app, what it should provide, and again the NFRs, which is non-functional requirements that we actually want a system to be. So NFRs are mostly systems. It's basically on how your system should actually work, and functional requirements is what you actually expect from your product. So let's first start with what exactly the functional requirements here we have. So the functional requirement here we have is that a user should be able to upload and download and view photos. Again, you can come across two different places in Instagram. We are just talking about newsfeed here. So you have a particular user profile. We are going to talk about that as well. But again, we have two particular flows which are newsfeed, in which we actually see the top posts from the users that you follow. Second is your own profile, that is the user profile, where you can just see the photos which are uploaded by the user. For example, let's say I upload a picture that is going to be on my user page, as well as if someone else is uploaded, it's going to be on the newsfeed. Again, if I upload it, it's going to be on newsfeed as well. But again, we are going to talk about basics here. So first is the user should be able to upload, download, and view photos. All right, follow each other. All right, again, these kind of app, whom are you going to share it with? From your to your friends, to your family members, to your acquaintances. All right. So in such cases, this particular app which you're talking about should actually have a mechanism in which you can actually follow. All right, we've already dealt with such kind of system in Twitter, so we are not going to talk a lot about it. Again, I'm going to just talk about the high level scenario, high level design. How can you build a basic particular app, and you can just uh, pass a basic interview on system design here. All right, and third functional requirement that we are actually dealing with is display newsfeed. All right, so we are going to have a newsfeed in which we are going to see the top post of all the users that you have here. Again, you can have a lot more things. For example, we can actually talk about like and comments. Again, for that we will have some more database implications in which we're going to set out more tables and so on and so forth. And we have to add separate service. Again, you can work on that. That is not too much difficult, but I'm going to keep it basic for the newbies here. All right, okay. So when we talk about non-functional requirements, so there are lots and lots of non-functional requirement here. So it can be your performance, it can be your availability, all right, your reliability, and so on and so forth. All right, but again, we have to prioritize some non-functional requirements here because they're going to hit on others. So, for example, if you have never heard of CAP theorem, I would definitely say you guys to uh, actually read this theorem. I'm going to tell it in some other video, but again, for such system designs video, CAP theorem is a very important thing. So, some interviewer can ask you, hey, why are you actually prioritizing availability over consistency here? So, we are going to talk about that as well here. So, first NFR here is we have to prioritize availability over consistency. All right. So, why? Why this? Because I want my Instagram, I want my particular app to work every time. I mean, it should never go down. So I want downtime to be less. Again, we can have its priority over consistency because let's say a person whom I follow, if he uploads a picture, if that comes after like 10 seconds or 15 seconds or a minute even. For example, a minute is a bad number, but what I'm trying to say here is if you're able to see someone else's picture after like 5 or 10 seconds, that is not much of a big issue rather than making our whole system down. So I'm prioritizing availability over consistency. All right, so my system should be highly available here. All right, low latency while viewing photos. So I should have actually low latency while I'm seeing it. So again, we can actually turn it down to, let's say, my homepage generation should be with minimal latency. I should be seeing my homepage, or you can say just as news feed, to be very fast rendering. All right, I want my system to be highly scalable. But why? Because when you talk about Instagram, there are lots and lots of users working, posting pictures, doing some activities, sending messages concurrently. So it is going to make a system more overburdened. So we want our system to be highly scalable as and when needed. And again, optimize for a read-heavy system. So again, for example, if I talk about myself, I might not upload a picture every day, but I use Instagram every day. I might not upload a picture in a week, but I actually open Instagram to see some stuffs. All right, it can be my friend's picture, it can be some activity, and today the reels are also in the play. So again, these kind of system, when we talk about social media platform, these are more read-heavy system rather than write system. So it should be optimized and scalable for such read-heavy requests. All right, again, I want my system to be highly reliable. We have done this, and highly reliable. So why I want the system to be highly reliable is because user uploads photo, all right, it should never be lost. So whatever a user upload, for example, let's say may it be a video, may it be a photo, it should persist. We should not lose it. So again, so these points are the NFRs that I want with the app today. And functional requirements are able to upload photo, follow each other, and display newsfeed. So we're going to talk about the very basic prototype. Coming on to the capacity estimations of roughly how Instagram works is, so we are actually making some few assumptions here. So read to write ratio is 100. So if I'm having 100 requests right now, so out of them, we are going to have only one which is of write. That means we are actually uploading a photo and persisting in the database, and rest of them are actually the read requests in which we are actually trying to see someone else's picture. We are going on to some follower and then opening their profile and then watching. We are talking about 500 million users who are actually registered on the app and 1 million DAO numbers, that is 1 million daily active users that we have. Let's suppose every day 5 million photos are uploaded. All right. So 5 million photos per day actually corresponds to 57 photos per second. And if we talk about a particular number, let's say, let an image size be 150 KB here. So it actually corresponds to 716 GB of images, just the data of images for a particular day. And if we actually persist that for 10 years, it is going to be around 2.6 petabytes. So this is the scale numbers that you're talking about. Again, we're not talking about video here. We are talking about average photo size here, which is 150 KB. It can be more than that. Again, Instagram does offer upload high quality as well, but it depends on you. We are just talking about the basics here. All right, these are the capacity estimations. So let's talk about a very high level overview a high level design over here, and then we're going to move on. So when you talk about this high level design, so what is going to actually happen is there's going to be a user onboarding flow as well as a ad friend flow. So as the name suggests here, so the user service is responsible for managing users onboard logging. Maybe he wants to do some kind of profile action related profile related action. So everything goes on to this user onboarding, and then it comes in contact with the load balancer, which actually distributes the load. And this particular user service, all right. So this user service is related to whatever we need to do with the user. For example, let's say we want to store some kind of data. For example, his name, his email, his user ID, and his preference settings, privacy settings. So all of this thing is done by user service, which actually sits on top of a SQL cluster. Why we are actually using a SQL cluster here is because the data is relatively relational. All right, so we are going to have more read request here. This is going to be more read heavy. Why? Because again, whenever a user onboards, for example, let's say you make a profile, you actually make it once. All right, you set your name once, or maybe like if you're frequently changing your usernames or updating your date of birth or bios and all, you don't do it very frequently, like in 6 hours or 7 hours. You actually do it like after 1 month or like 2 weeks, let's say. So mostly we kind of require here a relational database here. So we are going to use a MySQL cluster, which is actually fine for this particular case, and because it is read heavy, so MySQL is going to suit very well. Now, this user service is not just connected to MySQL; it's also connected to a Redis server. So Redis is actually you can just treat it as a cache. So whenever a user service uh, receives a request, it actually talks to Redis. If it has the data, it's going to revert back through Redis, and wherever the request wants to go to, it's going to go to that way. But if it does not have, after getting a hit from Redis and there is no data found in Redis, we actually talk to the MySQL cluster and get the whole data that you want. So with this case, it actually becomes so much faster because Redis is a cache here, and the rendering, I mean, it is going to be more fast and with minimum latency because we are using a cache. All right, if there is any kind of notification or event that we want to send is done through a Kafka, which is messaging queue, and user service is actually pushes the message into the Kafka and that this event is done. Again, this is all how the user service connects. Again, this is the very first flow that you talk about. All right, second flow is, let's say you have added a friend right now. So user one has actually sent a request to user two and they have accepted. Now again, in Instagram, this is a directed relationship. For example, let's say if I follow Elon Musk, he doesn't need to follow me back. Alright, it is a directed relationship. So we will be having a graph service that will be actually working on whatever graph that you need to work on. So whenever a user goes through this add print flow, it's going to send a request that hey, I want to follow him, follow this pair, and this is going to persist in graph service. So whenever I want, for example, let's say all my followers. So what I'm going to see is we are going to have a user node, and through this user node, I'm going to call the graph service. This graph service is going to get me all the followers that I actually we are going to know about all the users that I follow. As well as we can also talk about, hey, which users are actually following this user U1. So all of these things, all of the graph related thing is done by graph service. Again, it's on top of MySQL cluster just for the very same reason, because the data is highly relational. It is going to be a simple table where we are going to use a user one as the first node and it connects to the second node. So there's going to be a directed edge. User one is following user two. It is not a bi-direct relationship. We are going to talk about the database schema further in the video. But again, it's on top of MySQL cluster. And again, just like user service, graph service first actually talks to the Redis server, the Redis database. If Redis has a data, the graph service is going to return data from here to whatever part that needs this graph service. If not, it actually talks to the MySQL cluster, hey, that I need this information, could you please fetch me this? And after this is done, it actually returns the data to graph service, which is then persisted into Redis and actually goes back to the flow from wherever a request is coming. Again, the event is sent out to Kafka that day, hey, this event has happened. All right. So With the help of this Redis again, I've always told you guys. So whenever you have a very read heavy system, all right, whenever you have a read heavy system, you should always put caches in place. All right, you should always put caches in place so that you can keep your latencies in control. Because again, you don't want your user experience to be bad, so you want to always have the caches to be in control. Okay, so coming on to the next part is the system components. Again, we are going to have a lot of microservices here. Initially, whenever people try and build an app, all right, they start with the monolith architecture, in which the whole system is more coupled. I mean, it's very strongly coupled. But as soon as there is a lots and lots of scaling happening, and your site is getting your web app is getting overwhelming response, and you have multiple hits over here, you might want to switch from monolith to microservice. Again, we are talking about high scale numbers, so I've directly shown you the microservices here. We're not going to talk about most of them, but again, this video is for just the idea how you need to attempt a interview. All right. So we can have multiple microservices. Again, it depends on how your interviewer wants and what are the goals that have been set for this particular interview. So for this one, we're going to have our whole system is going to have multiple microservices, each responsible for a specific task. So we are going to have user feed service, which is actually linked to the news feed. We are going to talk about that. So it actually is going to generate the news feed service. We get news feed service. Uh, Along with that, we can have user service, which we have already talked about. We can have a follower service, which actually talks to whatever followers. Again, that is just related to the graphs. Media hosting service is just related to the media. I mean, the hosting part, or you may talk about the advertisement and all stuff. We are not actually into that. We can have a post service, which actually deals with how you are able to post image and that it gets persistent. I mean, this is just related to the upload flow. Comment service and like service, again, it is going to relate to the feed or the post. All right. So it is going to connect to a table, the post. We're going to have multiple tables. We're going to talk down a bit after. So you can have these kind of tables and these kind of services over there. We are going to use two types of data storage again. So whenever you don't know how to proceed with the interview, how to proceed with the system designs interview, probably you should start working with the data flow. So we have basically two flows over here. If we talk, we have upload flow. So we are going to upload photos here, and second flow is we are going to view and search photos. All right. So when you talk about uploading photos, all right, to post photos, we are going to use object storage. All right, so we can use object storage. For example, we can use Cassandra, or maybe we can use Amazon S3 or HDFS. I mean, a distributed file system databases. And for graphs, you're going to use GraphDB here. So we can use Neo4j that we can actually use here for graph databases, as we have complex relationship that we can see between user follow likes, as well as there are going to be multiple joins over there. Because again, see, uh, in these kind of tables, we are going to have a lot of complexities. All right, so we are going to require complex joins. So there are going to be a lot of joins. All right, we could have used relational databases such as MySQL, but because we have limitations on joins here, we are going to store these in HDFS. All right, and we're going to use graph databases for complex relationships and columnar databases for storing activities such as user feed, etc. So this is the thing. So for both the flows, again, for storing photos, we're going to use object storage, as well as for storing metadata, we can use this database service here. All right, let's move further. So after that, let's talk about the database schema. All right, so how can you build API designs and all? So basically, we're going to have multiple tables. Obviously, this is not just limited to these tables. You're going to have lot more tables than this. So we can have, like, for the basic functioning, we can have four tables over here, such as photos, which is going to have a photo ID, photo URL, photo location, user ID, and creation date. Again, you cannot store directly an image here, so we're going to use a photo URL, and that URL is going to actually use an image from, let's say, Amazon S3. So Amazon S3 is going to actually have the image persisted. That is going to have a link, and that link we are going to use in the photos table. We can use photo ID as a primary key here. The second table that we're going to have is a user table, in which it is going to actually keep all the information that actually is dealt in the user service that we started with. So user is going to have multiple parameters such as user ID, email, name, date of birth, last login, when they did last login. Alright, and again, he can also have basically a type of user. Alright, so again, if you remember the Twitter system designs, we have categories of users in which we are actually talking about a normal user or active user, live user, inactive user, famous user. Alright, we can actually, essentially there is actually different flow for all these type of users, because a celebrity is going to have a different way of uh, working. He's going to have a different, it's going to be more better, I should say, as well as from a very inactive user, or let's say someone who is inactive from like past 30 days, he's going to have a very bad experience, because everything is going to load in the real time. Whereas for a live user, everything is pre-computed and then he sees it. So the experience is different on the basis of type of user. So we can actually have that as well, but that is out of scope of this video. The second table is third table we are going to talk about is a follow table, which is actually going to keep the user T1 and T2, as well as it can also have a timestamp when the user one followed the time user 2. All right. Third is activity. Now this activity can be related to a like or a comment. You can just think about anyway. So we are just talking about a collective name here. So we can have an activity table which is going to have activity ID, user ID who created this activity, what is content, and photo ID through to which this activity is related, and the creation date. So we can have these tables. Again, we could have used relational databases again, but there would be a lot of joins, so we would never want to do that again. So we are going to use HDFS or Amazon SQL for such kind of things. So whenever a user uploads an image, the image is getting persisted into some database. All right, so we are talking about the image database here. So let's talk about a basic example. So we are going to have a post service. All right, now this post service is going to take what? Firstly, the user is going to upload a picture. Through the upload flow, that image is going to get persisted into Amazon S3, let's say. Through that Amazon S3, we are going to get a link, and that link is going to attach in the method, and then it is going to come to the post service. Hey, this image is being uploaded. Now, as soon as this image is fetched on the post service, this first pushes this information to the metadata database as well as the image database, and it gets persisted there. But again, this whole upload flow is a bit slow process. All right. Whereas if you talk about the read flow, we just have to see it. So what you have to do is we just have to fetch the information, the URL, right, to see the data. So in case of reads, the process is much more faster. All right. So because this uploading is slow, let's assume both the read slaves as well as the write slaves, if we keep them on the same, if we keep them on the very same server, our whole server is going to get busy with the write request. All right. So our whole server is going to actually occupy the bandwidth, and the read slave as the write slave is going to get occupied, and the read slaves won't get enough of the time. So because of this, we have to think about the connection limit. We should, which is why we should always segregate the responsibility. We should have different services. We should have different servers for read slaves, and different servers for the write slaves. So we can design the system in two different services. So you can see we have a post service here, which actually deals with just posting, and the image being service, which actually deals with just reading. So we can split read and write services into two different services. So with this, we can actually scale them independently as well. All right. Uh, let's talk about availability here and reliability. So because we can never lose the photos uploaded by the user, reliability again is a huge factor. So every time we should always keep more than one copy of the image that has been uploaded by the user, so that we can make system more reliable. All right. So for making system reliable, we can have different copies of the things, different copies of the photos in different servers, so that even if one goes down, we have that system. I mean, we have that image saved over there. So that actually this actually ensures reliability, as well as we can scale, we can have multiple databases. We can actually because we don't want to have a single point of failures. We can keep multiple components, multiple copies of this component. So let's say this post service has three replicas, as well as this image viewing service has three replicas. So this is going to do what? This is going to make system more available. So let's say again, in reliability, I was talking again. This might sound very confusing again. In reliability, I was talking about storing copies of post. Alright, so we should have copies of images. Whereas for availability, I'm talking about copies of server. I mean copies of components. So that even if there is a failure in this post service, we have two different post service running upfront, so that user can actually talk to them. So this is going to ensure availability, and copies of the post is going to ensure what? The reliability. So we can have this again for supporting millions of users. We can actually scale them to whatever our use cases. So this is what you can actually do. Now let's come to the last flow here. All right. So coming to the last flow, which is the news feed generation. All right. Whenever a user comes here, user actually sees the top post or the popular post that his following has might posted. So let's say if I follow Elon Musk's photo should come into my newsfeed. So this is what actually happens here. So newsfeed generation is just that whenever a user that a person follows posts a pictures, post a video, uh, it should actually rank. We have a ranking algorithm, and through that ranking algorithm, that actually is fetched onto a newsfeed. Now again, if this would be done in real time, this is going to be a lot slower. Why? Because every time what I have to do is whenever I open the newsfeed, I'll have to go to every user that I follow and fetch the new images and then sort them according to the ranking algorithm that you have. It can be on the basis of who has posted recently or whatever is here. So this is going to be highly latency. There's very high latency in this because it is going to be very slow. We have to fetch all the users. So firstly, we'll have to connect to the graph service. That graph service is going to tell us, hey, I follow these all users. Now I'll have to fetch the images, the top, let's say top 200. I have to fetch top 200 posts from all of these. So I'm going to fetch some, let's say 10 photos from each and everyone and any follower, and I'm going to sort them on the basis of the ranking, and I'm going to fetch top 200, and then that is going to render on my home screen. This is going to be a very slow process. So instead of that, what we actually do is we actually pre-compute. We pre-compute this information. So what we do is, as soon as the post service uploads a picture into databases, that is then notified to the newsfeed service. Here we have a newsfeed service. This post service actually pushes this activity. It actually notifies this newsfeed service to update the newsfeed of users they follow. So this is done pre-computed. I mean, this is pre-computed so that as soon as a person switches to his newsfeed, he's actually shown whatever the new post is. So let's talk about the whole flow over here. So let's talk about this API gateway service over here. So because we have lots and lots of services inside a particular app, for example, let's say we have uploads, we have viewing, we have newsfeed service. We actually want them to have a single entry point for all clients. So just because of this, we want API gateway. API gateway is responsible to provide a single entry point. So whenever there is a request coming, this API gateway is going to handle all the requests by sending them to whatever service that might be the best for this particular request. Also, it actually handles security, so it actually acts as a secure layer. So this API gateway actually routes the request to whatever service that we need to connect to. So for example, let's say a user A uploads a photo over here. This API gateway is going to actually push this request to the post service. So user A uploads photos, that is going to go to the post service. Post service is firstly going to persist that image in ImageDB. Again, it is going to save the metadata. It is going to upload this picture to, let's say, Amazon S3. That photo URL is going to get persisted inside the photo table along with this user ID, whoever has uploaded it. This is actually going to go to the newsfeed service, say that this user has uploaded a picture. So newsfeed service at that very point of time is going to interact and see whether it is reliable to show up in the newsfeed itself. All right. So this is how it works, and how again this new newsfeed service wants to know the followers of user A to make the whole newsfeed. So it is also in contact with the follow service, which has all the followers of this user one. So after getting this user one, the followers of user one, the list, it's going to get a list over here. So on this list, on the basis of this list, this notification service, let me change the color over here. This news feed service is going to apply a ranking algorithm. Now it can be any, so you can have some who posted more recently, and sometimes if a very popular user posts something, it comes on the top. So it is going to have a ranking algorithm system. On the basis of it, it is going to pre-compute a newsfeed. And then whenever a user wants to see his newsfeed, this can be rendered from this particular service. So let's say he wants to see his timeline or newsfeed, let's say. The API gateway is going to route this request to the news feed service. Uh, and it's going to go through the load balancer, because we are going to have lots of traffic. So we actually want to distribute the traffic to server more efficiently. So basically, we are going to do IP based routing for newsfeed. Uh, why we want to do IP based routing? Again, IP based routing, because the same user request is going to go to the same server every time, because a particular user is going to be in a particular geolocal and is going to connect to let's say common CDN and common resources. So every particular user is going to go to the same user service every particular time, to same server every time. So that is why we want to do IP based routing, because caching can be done faster. So this is why we actually use IP based routing over here. So this is what we are going to use. This is going to connect to the newsfeed service, which already has the newsfeed pre-computed for this particular user, and then from here it is going to render this newsfeed service to the user's interface. All right. So again, so we have a feed DB which actually helps in the pre-computed persistence. All right. So this is the pre-computed persistence for a user. Again, this post service is going to connect to the notification service as well. So let's say there is a new picture uploaded, or let's say someone has followed, we're going to have a follow service also here, which is going to connect to this particular table. So this is a follow service, which is going to connect to this table. All right. Okay. So we are not talking about notification service over here. Notification service we are going to deal in another video. But again, as soon as we do some kind of activity, that activity through Kafka actually we are going to have uh, a Kafka over here, which actually listens to all the activity, which is actually going to talk to the notification service over here. Through this notification service, as soon as the notification service has this data that hey, this particular event has happened, it's going to push this notification to the user B, because it is relevant to notification. User B. So that is the basic newsfeed generation flow. So coming on to this one, newsfeed can be actually pre-computed in two basic approaches, which is the pull-based approach as well as the push-based approach. In push-based approach, server alerts the user about the new post. So, for example, let's say anything has happened, the server is responsible to alert the user about it. So, this can be achieved using long polling, but it is not suitable for people who have large following. Again, why? Because let's say we are following 2,000 number of people. So again, it is very, it's very natural that because we are following 2,000, thousand users, someone in them might do something every particular second. So it is going to make a server more overburdened. So because every time a user does something, it's going to have to publish this notification to the user. To all the users that follow this particular user. All right. So We actually do not prefer this one, and people who actually follow large number of people. Uh, there is another mechanism which is pull based approach, in which every time a user refreshes the news feed, they're going to see the latest updates. So what you actually do is we go on the news feed and we actually refresh it to see the news feed, the latest updates. So this is what you actually do. But again, the problem here is every time you come on the news feed or the timeline, you're never going to see the new post. I mean, a lot of time you're not going to see the refreshed post. So new post may not occur, may not be visible. So this is one of the limitation in pull base. But in real time, what we actually do is we use a hybrid for that. So for celebrities, we actually use a pull based approach. All right, those who have large number of followers use a pull based approach so that they just refresh. For example, let's say I use uh, I follow 1,000 number of people. I'm going to refresh it and it's going to come on my screen at that very moment. Uh, Obviously, some latencies would occur because we are fetching that. All right, but for normal people, server alerts the user about the new post. So this is for normal. So we basically use a hybrid kind of model in such cases, and it actually typically scales well. All right, now when we talk about this again, this is basically most out of it. So again, the conclusion of such kind of system is whenever we make such kind of system, we should always ensure that my whole system is highly available. We have used replicas of servers so that we can still provide reliability as well as availability. So again, because we have multiple replicas, even if one of them goes down, we have at least some other service running. So for example, let's say if we have one particular replica of post service down, we have other post service. Again, they are going to be overburdened. We can use load balancer and we can use least bandwidth type. So if there is any particular load balancer which have the least bandwidth, so it can actually work well and we can do it. So we may use a hybrid approach of the newsfeed generation, and this actually works well. So we are going to actually pre-compute the newsfeed. We are going to pre-compute. We are not going to calculate in real time. That is going to make our Instagram work in the more better way. And we've actually talked about the FRs, NFRs, and that is all about the system design video about today. I hope you guys liked it, and please share in the comment how was the content, and is there anything that you didn't understand. You can just come out to me. If there is any doubt in the comment section, you can just at mention me here, and maybe that's all. Again, you guys can see the whole system design series. It is already live. You should start with the first one because we are actually going in the flow and we are actually building the basics. So with that, please like, share, and subscribe to the channel, and we'll meet you in the next video, guys.